In this video, we are going to be covering the topics of Chapter 14, which is titled Carboxylic Acids, Esters, Amines, and Amides. This is the last chapter in organic chemistry for this course. The first functional group that we are going to be discussing in this chapter is going to be carboxylic acids. So, when it comes to carboxylic acids, understand that they contain what is called a carboxyl group. And a carboxyl group is where we have a carbonyl group with a hydroxyl group together. Understand that carboxylic acids are very common in everyday life. They are produced in nature. So, for example, if you have a bite of a red ant, the reason why it stings is because the compound that is put in your skin is formic acid. Some of you are going to enjoy the sourness of certain products. So, for example, the reason why vinegar has a sour taste is because of the acetic acid that is present in the product. Let's first go through the process of understanding how to name carboxylic acids. The first step in naming carboxylic acid is identify the carbon chain that contains the carboxyl group. You're going to be writing the alkane name. You will be erasing the E, and the ending for carboxylic acids are oic acid. Because when in numbering, the carboxyl carbon is carbon number 1, understand that you're going to be numbering the chain starting at the carboxyl carbon. So, in the molecule that is given in the example, this is carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. So, if we first write as the longest carbon chain pentane, remember, we're going to remove the E in the alkane name, and then we're going to place oic acid. That's why the name is pentanoic acid. Understand that if we have a substituent, you need to give its location along the longest carbon chain that contains the carboxyl group, and we have to give this name as a prefix of the name that we gave for the functional group. So as you can see in the molecule given, its name is going to be 2-methyl pentanoic acid. In order to practice naming carboxylic acids, I'm going to do the first 2 problems in the worksheet. So, in the first molecule, we have to find the longest carbon chain. And as you can see, here I'm going to start here on carbon 1. This is carbon 2, carbon 3, carbon 4. So, I'm going to write the word underneath the line. So if we have the longest chain being 4 carbons, then understand that here the alkane name is going to be butane. We're going to erase the E, and we're going to replace it by the ending of the functional group, which is oic acid. And in here, on carbon 2, we have a substituent, a methyl group. So the name of this compound is 2-methyl butanoic acid. Let's do the second problem. The longest carbon chain that is present is 1, 2, 3, 4, 5, 6. Remember, the alkane name is going to be hexane, and this carboxylic acid does not have a substituent, so we don't have to place a substituent before the longest carbon chain. But remember, the E in the alkane name is replaced by oic acid, so the name of that second compound is hexanoic acid. Let's now discuss the properties of carboxylic acids. When it comes to carboxylic acids, the first thing that we should consider is that they are polar compounds. In these molecules, they are polar because they have two polar bonds. The first polar bond is going to be the hydroxyl group, and the second polar bond is going to be the carbonyl group. So, as you can see, because these bonds are polar, in which the oxygen atom is going to be electronegative compared to the carbon, and when we have the hydroxyl group, the hydrogen atom is going to be more electropositive compared to the oxygen. This explains at times some of the chemistries for carboxylic acids and how they interact with other molecules. So when we look at the solubility of this functional group in water, remember that because this structure, and I'm just going to highlight the atoms in neon green, because this functional group contains a carbon atom that is highlighted in green with a double bond to oxygen. As you can see, the carbon is going to be that black ball. The oxygens are going to be the red balls. And in a carboxylic acid, remember, we also have a bond to oxygen, and that oxygen is bonded to hydrogen. The hydrogen bonding events are going to be happening between, and I'm going to highlight them in purple. The hydrogen bonding events will be happening between the oxygen in the carboxyl group and the hydrogen in the water. And we can also observe how the oxygen in a water molecule can do hydrogen bonding events with the hydrogen in the OH portion of our carboxylic acids. Now, as we've seen previously in other functional groups, the number of carbons that is found in a carboxylic acid also will affect its solubility. So remember that the rule of thumb in organic chemistry is that if you have 5 or more carbons, the solubility is going to be decreasing. And in carboxylic acids, even though you have 2 polar bonds, as we get into carboxylic acids of 6 carbons or more, understand that the solubility in water diminishes. Understand that because they are called carboxylic acids, then it makes sense that they have acidity. But note that carboxylic acids are not strong acids. They are weak acids. So what happens in carboxylic acids is that if you place them in water, they are going to ionize. And what this means is that putting a carboxylic acid in water is going to make that carboxylic acid donate a proton, and the water molecule is going to accept the proton. That's why in the products of the reaction you can see that water form its conjugate acid, okay, which is going to be hydronium, and the carboxylic acid is going to make what is called a carboxylate ion, which is going to be its conjugate base. So again, if we label these, carboxylic acids act as acids, and in the presence of water, water is going to be the base. Now, because carboxylic acids are acids, they can undergo neutralization reactions. And neutralization reactions was a topic that we discussed in Chapter 10. Understand that if you place a carboxylic acid, like for example methanoic acid, in the presence of a strong base, like sodium hydroxide, the product of the reaction will be the formation of water, and you're going to be making a carboxylate salt. The reason why it's called a salt is because this is an ionic compound. So in essence, if we think about how the reaction is happening, this is a double replacement reaction in which the OH, I'm just going to highlight them. The OH binds with the hydrogen of the acid, and that's where the water comes from. So then, because the oxygen is going to result in a negative charge, then the sodium is going to sit next to it to balance that negative charge. Understand that this can happen with any strong base. So for example, in the second structure, which is benzoic acid, and I should note that this benzoic acid is a carboxylic acid that contains benzene. And you guys should be able to identify it and name it. So this is an important structure that you should know. I'm just going to circle it. Now, if we have a carboxylic acid react with KOH, understand that the only difference is that now your carboxylate salt is paired with potassium, because again, you're reacting with potassium hydroxide. Why are we interested in carboxylic acid salts or carboxylate salts? Because they are used as preservatives and flavor enhancers. So if you look at some of the food products that you may have at home, they may have compounds like sodium benzoate. In sodium benzoate, it is added to foods because it's going to be inhibiting the growth of mold and bacteria. It's also added to fruit juices, margarine, relishes, salads, and jams. Another type of carboxylic acid salt or carboxylate salt is going to be monosodium glutamate or MSG. MSG is known to be a flavor enhancer, and it is added to meats, fish, vegetables, and even baked goods, because one of the things that MSG can do is actually in your palate enhance flavor. And if you eat a food that contains MSG and you can prepare the same dish without MSG, you will always point out that the MSG one tastes better. The next functional group that we're going to be talking about in Chapter 14 is going to be esters. When it comes to esters, understand that they were discovered around the 1800s because one of the things that was known in the past is that, for example, in a willow bark tree, there's a compound that is called salicin. And salicin, when it was placed in the body, it actually converts to salicylic acid. And this compound, even though it was being used for pain reliever because it irritated the stomach, it was a problem. So the company Bayer soon discovered that an ester form of this salicylic acid, which is called acetyl salicylic acid, was less irritating to the stomach. And because of that, that's how aspirin, which is the structure you can see in the bottom of the slide, was discovered, made, and manufactured. So salicylic acid will be if this portion of the molecule will be replaced by a hydrogen. So understand that that's the difference between the two compounds. Understand that when it comes to esters, we not only find them in products like aspirin, but we also find them in products like fats, oils, and very importantly, they are going to be responsible for the aromas of fruits. So the flavors of bananas, oranges, strawberries are all derived from ester molecules. As you can see in this slide, we have the ester responsible for the smells of all these different fruits. Now let's go over how to name esters. When it comes to esters, understand that the main thing that we have here is that we need to separate the portions of the esters, okay, into the alkyl component and into the carboxylate component. Meaning, remember that an ester is going to have the signature of a C double bond O bonded to oxygen, and that oxygen must be bonded to carbon. So whenever we're naming an ester, you're going to, in a way, select the portion that is going to be bonded to the single bond oxygen, which is the one that we find in the right, in this ester as written. And we're going to separate it from the portion that it comes from the carboxylate, okay? And when we are building the name of the ester, the first word indicates what is the alkyl part of your ester. And we're going to be looking at when we synthesize esters that actually is going to come from the alcohol. The second word in your ester is going to be the name that is derived from the carboxylic acid. So this gives you a hint into how our esters synthesize. As you can see in the slides, they're made from carboxylic acids and alcohols. But again, when we are writing the second word, understand that the ending of an ester is going to be O-A-T-E for the portion that comes from the carboxylate. So in order to study this more in detail, let's actually go over naming problems. So these are the examples of the esters. So I want you guys to pay close attention when it comes to how is the ester given to me and how is drawn, okay? So I'm going to do all three problems on the worksheet to go over how esters are named. Now, this is one of the main things that I want you guys to be aware of. When it comes to these molecules, understand that I'm going to first highlight the first word. And remember, the first word in an ester, I'm going to highlight it in purple, is going to come from the alkyl chain. The alkyl chain here is going to have 1, 2, 3, 4 carbons. We have to start numbering from the carbon that is right after the oxygen. So 4 carbons mean that first word, since we're attached to carbon 1 in a 4 carbon chain, this is going to be 1-butyl. Then we are going to be counting the carbon in the carboxylate as carbon 1, and then we're going to count. This is carbon 1, carbon 2, carbon 3, carbon 4. We are going to be using the alkane name for a 4 carbon chain, butane. We are going to erase the E, and then we're going to put the ending for an ester, which is O-A-T-E. So this is 1-butyl butanoate. Let's do the next problem. I'm going to first select the alkyl group next to the oxygen. In this case, we only have 1 carbon. So that is going to be methyl. Then, as I look in the portion of the molecule that includes the carboxylate carbon, we have 1 carbon, 2 carbons, 3 carbons, 4 carbons. So this means that if I write the alkane name, is going to be butane. And again, I'm going to erase the E and put OATE. So the name of the second compound is going to be methyl butanoate. On the last problem, when highlighting what is attached to the single bond oxygen, as you can see, we have a benzene ring. Remember that when a benzene ring is used as a substituent, that is known as a phenyl group. PHENYL. Then, if I count the number of carbons in the part that is coming from the carboxylate, I have 1, 2, 3, 4. So in the last molecule, the name is phenyl butanoate. Always remember that when it comes to naming esters, the portion of the carboxylate ends in OATE.